Our design is called high-efficiency micro-inverter for photovoltaic panels. To be more specific, we collect the solar energy, transform it into AC voltage, and feed it back into the grid. Basically, our whole system consists of 3 subsystems: a pair of interleaved flatback inverters to convert DC to AC, a full bridge to unfold the sine signals, and last comes the EMI filter, together with some voltage and current protection and sensor circuits. On the left side lies the main circuit, while the right side the DSP and feedback loops. The microprocessor uses a zero detecting and phase lock loop to generate time-shifting duty cycle PWM signals to drive MOSFET switches, thus controlling the feedback converters and the full bridge to make the output synchronize with the grid. Sensors and protection circuits are made to ensure each stage are working properly. Okay. This is the software we use to write the codes into the DSP. And this is the schematics of our DSP. You can see it from microchip. And we have different pins and the functions on it. We connect the laptop to the DSP in our system. And now we will write the codes into our system.
Okay, so here's what happened. There was 2 NPNs, okay? But Adrian said that when he showed it to him, he complained.
You can see that the code has been successfully written into our DSP. Now, these are our subsystems. First of all, we used 2 DC sources in parallel to provide a large range of input currents. We connect these 2 DC sources together and connect it to the input as a solar panel input. And these guys are a combination of a transformer and an auto transformer. We connect it to the grid, so the outcome of this should be a smaller AC voltage. It's just a model of the grid. And finally comes this guy. This is a power supply of all of our chips. It will provide with 12 volts, 5 volts, and 3.3 volts analog signals. And last but not least, we use the different channels of the scope. The channel 1 is connected to the grid, the grid model, basically the outcome of this guy. And we use the channel 2 to connect to the output of our system. We have connected the transformer to the grid. Now we are turning on the PV panel input and then power supply. Okay, here in the picture, you can clearly see our final output. In the picture, the yellow curve is a grid model voltage, and the green one is our final output.